Welcome to my video. In this video I want to explain about signal filtering. So some of my friends or few of my friends asked me about this topic, and I already explained this topic many times to different people. So I think when another person asks me again about this topic, I will prepare this video for them. Okay, now how I explain to you about filtering wave is using sine wave, the combined sine wave. So here I have 5 Hz wave here, 20 Hz wave here, and 10 Hz wave. We will combine all of this wave and we will get wave like this. So first we will use FFT to filter this wave. And if you ever learn about FFT, that you must know that you can transform this wave or this time spectrum wave to the frequency spectrum wave like this, and you can refer it back from this frequency spectrum to the time spectrum using inverse FFT. And in this frequency spectrum, as you can see here, we combine 3 waves. So in this frequency spectrum, as you can see, we have 3 frequency that is above 0. This is 20 Hertz, this is 10 Hertz, and this is must be 5 Hertz. So the idea of filtering in here is we get rid all the frequency of the wave that we don't need it. For in this example, what I need is just 5 Hertz. So we will be zeroing the 10 Hertz, and the 20 Hertz, and the remain will be 5 Hertz. After that, we will do the inverse FFT, and this is the result. But as you can see in the boundary, the result is not too good, but it can be helped. The boundary problem arise in many cases, and in the FFT it's not the exception. And for now, I will give you the common way to filter signal, that is using butterworth signal, for example. And in this case, I do the Lopez signal, and this is the order, and this is the threshold. So here I am using Lopez, and the threshold is 7. So as its name, it's Lopez, so all the frequency above below threshold will still remain, and above threshold or above 7 will be zeroing. So if we apply this code, we will get a signal like this. And as you can see, same as the FFT1, the boundary is not too good. Yeah. And now for the second example, I combine 5 Hertz, 10 Hertz, let's see, 20 Hertz. I combine here 5 Hertz, 20 Hertz, and 100 Hertz, and the combination will be something like this. And if we apply FFT, you will get the frequency spectrum like this. This is the 100 Hertz, this is 20 Hertz, and this is 5 Hertz. So we will zeroing the 100 Hertz and 20 Hertz, and we will get something like this. This is strange because there are high frequency beside the 5 Hertz. Why this has happened? this is happened because here you can see the frequency that is above 0. It's not just 5, 20 and 100. It's around them, it's 2 above 0. So about 100, around 100, there are some frequency that above 0 too. This is I think this is the residual computation from the FFT. So it's something like, I think this is something like error value of FFT operation. So if we just get rid 120 Hertz, frequency around 120 will still remain, and if we doing the inverse FFT, the remain will stay in here, and you will get something like this, a high frequency around 100 Hertz. But if we apply Butterworth, in this case Lopez, the result is same. And now we move to why we must, or why we need this filtering wave. So for example, in this case is to analyze monthly rain data. So if you ever learn about meteorology, you know that rainfall happen because many factors, and you can group it in something like local factor, regional factor, and global factor. And the reason why we want to use this filtering wave is we want to trap the pattern. As for the example here, for example, we want to see the cycle from 4 months to 6 months, and to do that we must do bandpass signal. So all the signal except this will be get rid of or attenuated. So we will get something like this. Oh yeah, this is the plot of the rain data. This is rain data of 30 years. And if we apply this Butterworth filtering, and in this case is bandpass, we will get something like this. But this plot, you can interpret it as a rainfall, because as you can see, there are negative value in this plot. So of course this is not rainfall, this is just a pattern. And how you use this pattern or this plot? The answer is you must correlate it with some phenomenon that have a 4 to 6 month cycle. And if you do filtering using FFT, the result is different, but I think this is the right one. Okay, see you in the next video.